Okay, in the shop, all alone, so I'm just hanging on to my cell phone trying to get this done. I figured I owed everybody an explanation of where I'm at. It's been a long time since I posted a video, and I'm still at it. I just haven't been in the shop making much of interest. I've been tied up in my office actually doing SolidWorks. We're going through a whole redesign of the telescope in effort to do a remodel project. So kind of like a $400 million remodel project. So I'm drawing a lot of the steel structure right now. I've already gone through the concrete pier and incorporating the redesigned telescope, mirror packages, all the optics. So kind of a big deal. So that's what I've been working on, and that's not that interesting. I don't think a lot of people would like to see that. Could be wrong. Maybe it's something we'll cover in the future. But something I have been working on, I can flip this camera around, on the CNC tonight, since it's about 9 o'clock. I came in at 8, so I'm working on 13 hours here. You can see all the snow in the machine. This is all plastic for, and I think I've covered this in another video, for these fishing reel bodies. So here's a cover plate, and this side is be second op. First op is done, then I flip it over and just run the second op. Now both of these pieces came out of one 12-inch square, 3/4 inch thick sheet of material. Ultra high density polyethylene is what it is. This is 1-inch thick stuff, so this will be used on the bigger reels. This is the smaller, I think they're called Shimano 50s. So basically I can do first op, and again both pieces come out of the same sheet on this one. This first op is 10 minutes. Second op on this one is 4 minutes. Whoops, there goes a cover or a body right there. Anyways, the second op on this one is about 6 minutes. So in the course of about 11-12 minutes, something like that, maybe 13, you can build a complete reel. You can machine the bodies for a complete reel. Elliot has had some quotes to do this work in the $700 range. Now, he was able to find a couple of different people that were able to do this for a realistic price, something under $200 per unit. Now that's supplying the material too, but this material is pretty cheap. I selected this material because it's durable, it flexes, it doesn't snap, it doesn't break, and it's cheap. It is one of the cheapest plastics you can get. So supplying the material and cutting it, something in the $200 range, and they have to be shipped to Hawaii, which is pretty costly. So what brought this on is I was sitting in here while I was running these things and watching in little like 5-minute snippets Steve Morris's new video, and it's the EB Takeover Steve Morris engines. So this is Engine Builder magazine basically, and he just did this video they posted it March 23rd. And Steve Morris is a fellow Michigander, and zoom in right there. So there's Steve. He's a professional engine, and he's big into endurance engines. So the kind of engines you'd put in a 4,000 plus horsepower car and take on, say, Rocky Mountain Race Week, which is what started this little YouTube channel. So you drive from track to track to track and race in between, and fastest average time at each track gets all averaged together over the event, and the quickest guy kind of wins the event. You win a fancy trophy for your hundreds of thousands of dollars in effort. But hey, it's all fun. Anyways, so Steve was just on his little channel here talking about the supply chain issues. one of his viewers had a question, and he basically did say that yes, the supply chain issue is a real thing. And he went on to talk about how I believe they outsource the engine block machining. It takes a really large machine to do this. And if I'm not mistaken, I believe he's got a good friend that does Sick Week. And they have a massive Haas CNC machine that they're trying to get running. Maybe it's running now. Anyways, maybe they're trying to make blocks for Steve, or maybe it's a partnership. Anyways, he was talking about how he's got a lot of people that promise and talk the game, but when it comes time to actually deliver, they can't get it done. So Elliot's parts are back with me. I did a lot of the original design work. Took it from napkin sketches and basically to kind of a finished CAD model that can be manufactured just about anywhere. And I did all the prototype work on these things, and now they're back. So I'm happy to do this for Elliot. This little product is a great product, and he could literally sell as many of these things as we could make. But right now he's struggling with supply chain issues in the form of the motors, switches, all sorts of things. The plastics is just one thing. Now we've taken control of that here. We're going to be making them locally. I hope I can keep up for him. Hope I can keep the cash flow moving and food on his table. And also the fishermen, they take these reels out of service. They're not catching fish when they're getting worked on. And if we don't have the parts, when they send their reels in from Oahu, from Kauai, from wherever they come from, then we have to sit on their reels, and they're not putting food on their table. So this is kind of a big deal. If anybody watching has a machine shop and they want to cut some plastic, get a hold of me. Leave a message. And we'll see if we can set you up with probably a dream job here. It pays pretty well. The material is easy to cut. There's no coolant necessary. It's clean. It's a dream job. Anyways, here's something that we've been working on. Elliot purchased this little guy. It's a snap maker CNC machine. We use Fusion 360, and it has a nice post for this guy. And it took me a bit to figure that out because I'm a SolidWorks guy, and this Fusion is definitely a learning curve for me. But we got a little piece of MDF bolted on here, and basically one of his reel bodies will sit in here. We use some chunks of brass, I think, to weight it down. Haven't put any clamps on here yet to clamp it down. But he can just stock one size, and it'll be the smaller reel. And then when there's a need for a big reel, the 130, he can just drop her in here and open up the cut to fit the 130. So it's $1,800 for one of these things, but basically it streamlines his inventory system, and it helps him release different size reels in a matter of minutes, basically. So that's what I've been working on there. I can go back in, I guess, next to the computer, and we can show these little guys. So solid chunks of stainless, and I've got this saw cut right here. This has to be cut on the CNC, so it's perfectly square and 45 to the existing surfaces. This is an optical test piece. So basically these surfaces will get cut, and it's going to have 4 holes in here that I'm going to thread mill. And then I also have to relief cut this side 2 pockets, basically halfway through not quite halfway through on both sides. And that'll be the finished part. So stainless is ugly. I absolutely hate stainless. So we'll get to that eventually. What else? I guess in one of the previous, these guys were finished up, and they're just sitting in wrappers right now, waiting to go on the instrument. These again, these guys are going on Spiru, and this will be part of the instrument that hangs underneath the telescope. These are little, basically they hold an optic inside this tube, and there's a gold-plated little sleeve that goes inside there. And we're having issues with this not being cold enough. So the way I understand it, I'm not an astronomer. I'm just a machinist and a machine designer. The way I understand it is the sensor, the CCD, basically the same thing in your cell phone, that captures the image is infrared. Now infrared sees heat, not really light, even though, you know, light does have heat. But basically, if this is not cold, 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 you will see this thing. So we have to get this very, very cold. So right now, basically what I'm saying is we're working through a way to, and out here on the bench, I've got stuff. The first, this is the design that we've ended up with. It's all bolted together, got channels in it. This is a heat exchanger that we're going to manufacture here. The first try was here, and this is 3D printed copper from Desktop Metals. Really would like to thank those guys. I think I have expressed great gratitude in their attempting to work with us to find a solution. This thing came, basically that's straight off the printer. Then it goes through a sintering process where it kind of bakes this thing and turns it into a solid block instead of, I guess it's some sort of resin that supports powder in its printed form. But that's the as printed edge right there. And then I clean this thing up on the Bridgeport just to give it some square edges so I could hold it and then surface this edge very, very flat. Because as printed and sintered, they're not exactly flat. Pretty good, but not exactly flat. The issue with this guy, why it won't work, and there's a lot of beauty to this. No bolt holes, nothing to leak, only the fittings. But the problem is, this guy seeps water. It's too porous. There's probably some coatings that I could do to help seal this up. But if we leak any of our coolant out of this thing, it could be very bad getting coolant on an optic or an electronic piece. So what we're going to do is the known. We're going to make this out of aluminum. There's the stack right there. It's a lot of heat exchangers. And I don't know what this piece is, but all these sheets are going to be heat exchangers. And this is kind of interesting. We actually went through the R&D work to figure out how deep of a slot. You can see that one's 200, 210 thou, 220 thou deep. And then this guy here, 225, 230, 235 deep. And I think one of these two, 230 or 225 deep, that's going to be the best. So, you know, it takes a little while to do this kind of stuff just for R&D work. And in the end, what we decided was just to machine the pockets in. Use a small end mill, machine the pockets in. So that's going to be kind of a fun project. It's going to be a big one. It's going to last for quite a while, but it'll be fun. And then, let's see. The CNC machine right now is off. I've got the computer powered down. Hello, everybody. The lights are still on, but we need to turn the air off. I'm not going to clean it out until I'm done cutting or it's too full. And I just vacuum it out. It's pretty simple. But we got to turn the air off. And to do that, we're going to walk into in here, just past my restroom and shower. In here, I have a little fabrication room. So we got a little MIG welder, TIG welder, some ladders that really shouldn't be there, got a blast cabinet, a press, and a little tiny, not a Bridgeport I wouldn't call it, but it is a knee mill with a DRO, and we keep this around for a lot of the guys that aren't that good at machining. We don't want them tearing up the good equipment in the inner shop. And in here on the table, this is pretty cool, and we'll get into this in a future video. Picked up a used bending die. Gonna use that to bend pipe, which is up there. So I've got a lot of pipe, and this pipe is eventually going to form the frame of my 1932 Ford Roadster. So we're going to build inside of the original C-channel, which has been boxed, the original C-channel frame. Because 1932 Ford, you know, what do they have? 90 horse in a flathead V8, and the motor that I've got going in there is slightly more, probably on the order of 700-800 horsepower. So we have to build a frame for that thing. Another thing that I've been working on is maintenance on the cars. I had to put a starter in one of the cars, and oil changes, and just keeping up with life in general. Now over in the vehicle bay, so this building's about 100, well, it's about 80 feet long, and then we've got 20 foot of lean-to on the other side. My shop area that I work in over here is 30 by about 42 or so. So that'll give you an idea of kind of the area that I have to work in. This is the inner shop that we were just in. The CNC machine's over in the corner. We walked around the raw material, sitting right there for all the big reels, welding shop. And then I have to come over here at the end of the day to turn off my air compressor. So here you can see I use a timer, and this is something that we came up with. It's a much better idea than just shutting the air compressor off, and then over the course of like the evening, the tank drains itself completely dry, and then you come in the morning, you click on the air compressor, and you know, the thing runs for 15-20 minutes while it builds pressure. What we do is this timer just clicks on an outlet, basically. So the outlet controls the dryer that we can hear kind of purging, and it also runs the air compressor itself. It does not run the air compressor. What it does is it shuts off a piloted valve. So I just close the outlet, essentially like an electronic ball valve, and it traps all the air in the tank. So that's it. Dryer goes off, air is held in the tank, and the compressor stays running. It's quite a bit cheaper to switch that piloted, essentially electronic ball valve, because that can be done with pretty low amperage stuff. Whereas if you wanted to switch on and off that air compressor, that's going to take some power. I think I have a 7.5 horse piston Ingersoll. At some point we're going to get a screw for this place, but that's what we have right now. Anyway, so there's a little tour, a little talk about what's been going on and what's coming up, what I've been doing, and haven't forgot about everybody. Still want to make some cool stuff. Still want to put out some interesting videos. Just kind of in a lull right now, but things are going to pick up eventually, and we'll get right back at it. In the meantime, I'll keep everybody posted of what's going on, and keep looking for interesting things to show you. So stay tuned for more. I guess, you know, what everybody else says, smash that like button and subscribe, and stay tuned for more content. Chopsmitty out.